Okay, think we are back in live. So it looks like everything seems. It looks like everything is fine. So so last few days we are basically battling with this trying to create this library. I think it's almost more than a week I'm working on this, but still we made some progress. So let's just dive into this and think. So the gray, okay, I don't know. Mm, Probably, okay, let's just actually, if it is, that should be, that's itself, for linear layers, okay. We have a setup operation here, and okay, for now, let's just take care of the forward pass. Maybe later we can define it. So this is actually, this will work. Yeah, once we actually send the data, then gradient option. Gradient, add recur gradient operation, and type recur. So the type recur thing, basically why I created the type recur thing, if it has come from a linear layer, okay, let's build this, and next to what we have to build is what is it? Let's just build sigmoid. It's going to be sigmoid, and just as it is, it's going to be a tensor grid node. For now, let's leave this as a so it's going to be written shape. Yeah, I'm not sure. Maybe we do shape is equal to input dot shape. Data, how this sigmoid will apply. So it okay. Let's just, this is a sigmoid, so it's going to be take okay, sigmoid is a bit of a different, but data dot iter and dot map on it. So it's going to be take actually the x wait a minute, this is a valid code because just one small okay, sigmoid, and it's going to be take the each element, and so now we have the element, right? So say for sigmoid, okay, maybe we can write that formula here, and 1 slash. I'm not sure it will introduce any kind of bug. I'm not sure about that, but let's just try. Okay. Then collect and tensor. So it seems fine. Let's just ask GPT. This will work. This will work. As long as if needed, as long as you add or if needed. Okay. So say so the what is the this x exp is a element wide operation, but it's going to be take a tensor. So in order to actually we need in order to use the x, so it's a f, actually it's here mm, um function for now. I know x we need to implement the x. So for now let's just leave it like this. Okay, and same thing, maybe we can just we just copy this. Can we just copy this and paste here, and change this to and it's right. So it's going to be take a tensor, and this line is going to be. So what is the formula for what is the what is efficient way to compute the damage? It's going to be take a tensor. Shape.clone and iter and tanh. So we need to define the tanh in a different function. Actually, what? Wait a minute. don't do this manually. You actually, so here you're taking the tensor, but it's not. Okay, here the x is what? So the here x is f32, and is there any is there any built-in function for tan h in it? Yes, we can tan h built in from primitive type, yeah, but okay, for exp also, and it is efficient. Okay, 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 okay. For now, so okay, just copy that code. So we have this now, and okay, let's build the next one and the exp thing. This actually this is going to be different. Exp exp is actually where you take an input, and it's going to be a tensor, and let's just why we just wait a minute. Okay, delete this. So yank and paste it here, and going to be exp, right? And so it's going to be tensor, and exp is basically exponentiate. It's hard to spell for me. Let's let's we have actually we have inbuilt implementation for it. For now, let's just use that, and then once we actually get this prototype working, then we can optimize that. So x, that's it for x, and we need to build in natural log. So let's build this. So PyTorch, how PyTorch handle this? Let's PyTorch documentation. So for each Python function in for each log. Okay. Interesting. These all defined default, say default functions, right? So these all we are using this inbuilt methods for log exp event and the thing is it's on I think it's only work on F32. Now we are basically focusing on F32, but pretty soon we'll get into the all of the types. Okay, so then what? So it's going to be neck. When we call them, these all sort of urinary operators. Now we are defining urinary operators sort of thing, basically for your taking tensor, and you don't need anything, more than that. All you need is take a tensor, apply these sort of functions. That's it. And but I'm not sure whether this could work. Square and absolute. So let's just ask GPT layer norm. More complex. Do we layer norm is a bit of a different thing, but right, efficient, optimized implementation for all of this functions. Dropout. Okay. So ops, it's going to be take absolute. That's it. And for square, simple square root, we have that one. And okay, now we have so now one of the things about these LLMs are actually they are really good at generating code in a very minimum, I mean, very small amount of code. like this, right? So you are basically we are asking specific functions, you know. We are not no hey, right, we are not asking for like writing framework, right? So we are not asking for, you know, write PyTorch and Rust, minimalistic write PyTorch and Rust. We are not doing something like that. But if you say something like, if you tell something like to ChatGPT or any other model, it's going to be bit struggle for it to create actually a good code, production ready code. It's but you can use it in a small way like this, so it's going to be really easy. And ChatGPT or any other LLM can do that effortlessly, and it's really hard for LLM to make mistakes in in this sort of a shorter context. If you are planning to build the entire structure and you are giving everything to ChatGPT or something like that, it's going to be, you know, it's not gonna work. But now I'm doing very sort of it's you can, I mean, this is a very small context. You can give much more than this, but you need to be aware of that. So you need to be basically, okay, we are not make sure you are not giving any crazy stuffs to LLM, because they are going to be a bit struggle. Okay, this is actually how drop dropout is an interesting thing, but I'm not sure whether we can implement this dropout here, because dropout actually build into the I mean fall into the category of regularizations. So now we are doing, yeah, dropout we need to, okay. So they actually fall into the regularization, and so I think I need to write a different entire system for regularization, something like a entire structure with their own methods. But regularizations actually, how, okay, let's just see how uh, what is it? So hmm, dev. So okay, so Galo. Okay, they have how they define how the API looks like for dropout. Is it actually, I think dropout, it's actually, wait a minute. So sorry for that. Okay, okay, what we are doing. So dropout important. The dropout meant for training. You shouldn't directly. You should return. Okay, important. This dropout is meant for training and evo inference mode. You should return input at clone directly. Training, so you should return directly. So actually, mm, mm, okay. So the dropout APIs are let us sure, that's fine. I know he have I know he has a dropout in this code, but I am not able to find it. Okay. In and out dropout. Okay, this is how we can use it, right? So it's in and out dropout, and that should be also, let's just involve this in a tensor, but the problem is in and drop is it's going to be actually dropouts are only for, so what are the layers going to be what are the layers going to be used dropouts, what are the layers going going to be used dropouts? only the linear. So it's going to be take the tensor and randomly turn off some of the columns in the tensor. It's a column or row, but linear rare, right? Which layer typically use then and dropouts. So dropouts applied to after any linear tensor layer, but inside the what do you mean by dropout is not part of a linear layer itself, but it applied to the linear layer like this. So like this, it's going to be but ReLU dropout. Okay, it's wait a minute. So X going to linear, then reload, then oh, here dropout is actually activated in activation units. Okay, basically dropout is applied to activation units. Why not inside? So dropout itself should be another sort of thing. Maybe we can define logic here and but it's going to be written actually it's going to be take a tensor and it's going to be wait a minute, actually these all going to be take a tensor, but okay. So drop basically randomly turned off some elements, right? So some neurons, some activations, sorry, random number, then return dot max if prop if orange and okay. So yeah, calling some method here, and that's going to be take some type. Okay, let's just put that here and so we don't need and okay, use art. It's what is it? And RNG. Okay, then layer norm. Layer norm is it's a different thing, right? Basically, you have a layer and you are basically creating another branch and take that input, and once the input goes into the layer, then you got the output, then you basically add the activations. So I mean, add the input to the output basically. Okay, for layer norm, say layer norm, it's going to be layer norm itself need to be a separate struct, right? Because it's going to be a layer thing, so it should be, so these are all okay. Let's just define that, but whatever it is, it's going if it is a layer, let's just yeah, layer norm. So, layer norm, and it's going to be take a input and it's going to be a tensor, right? So once you have the input, all you need to do is just take, so actually layer norm is not a, wait a minute, layer norm is actually for, is not actually fall into the urinary operator, right? Because it need two matrix, which is the previous input and the activation. So layer norm, but other things here, everything is at, you know, except dropout, but everything is just acting in acting in a single tensor, right? So let's just leave it layer norm for now. Next, go to the binary. So binary, we have addition, sub, multiplication sort of things, but for multiplication I am basically not sure whether to use any sort of library or not, but for now this is what I just built that. And so okay, I have something here, just I asked ChatGPT to basically give all the, what are the tensor, I mean urinary operators, ternary operators, these sort of operators I want, I have to implement. And it gave me a nice list, which is that optional attention, batch norm, layer norm, gradient clipping, mixed precision. These are the things we need to implement in the future, but for now, so these are going to be you know, let's just this. Sorry for that. Okay, what are the things we already implemented here is that add, we have the implementation sub and mul divide. Matrix multiplication is a different thing. Actually, for matrix multiplication, I think I downloaded some library for it. So this is the matrix multiplication library. Okay, for now, let's just take care of other stuffs. Dot vector dot product. Dot product. Actually, dot product also. Dot product basically fall into the this matrix multiplication, right? What is the dot product? It's going to be a multiplication of two vector and add the values, right? So what is matrix multiplication? If a multiplication happens between two vectors, it's going to be a dot product. If multiplication happens in a group of vectors between group of vectors, it's going to be a matrix multiplication. No, row column. Row is a vector, column is a vector. Add those, dot product. Multiplication, multiply and add those, dot product. So that just basically handled by matrix multiplication, power, element wise exponentiate. So that thing, yeah, we need to implement that. So let's just try that. But how can we? So let's just leave it like this, because how can I use this this lib for matrix? It's a matrix multiply API. So it's going to be take a 3 matrix. It's sort of a very one of the this matrix multiplication, the algorithm for matrix multiplication in GPU or CPU, that itself is one of the greatest algorithm ever. One of the greatest algorithm exist. That's that thing basically exists in everywhere. So matrix multiplication algorithm is you are basically having them separate them into a 3 matrix and multiply them and add them. So matmul k m use size k, but unsafe code. How this how this manual works. mean what I mean by that is mean by that is I have a simple layer. I have a single matrix. Perfectly for single matrix. No, it's no, no, what um saying is that how this mat manual algorithm works. I have a two matrix. How can I send a argument to this function? That you are asking how to pass a two matrix into a, so you have a two matrix, which is the, okay, we have two matrix, and the third matrix, it's going to be a 2 by 4, I mean 2 into 4. That makes sense, right? So how to call, so you have a two matrix. What is this third matrix? It's basically m into n, which is a row of a first matrix and a column of the second matrix. So we are creating that and fill those. So pointed to a matrix. I'm not sure which. I think it's actually the matrix A. If you are creating any sort of vector, dynamic array, it's going to be in a heap, right? The thing is, in Rust, yeah, basically you can have multiple pointers, like multiple type of pointers, where you have a pointer that lives in a stack, and you have a data that lives in a memory. Sorry for that. Once the stack goes out of scope, once the pointer goes out of scope in the stack, it's the Rust will clear the memory, clear the data in the heap memory, right? So that's a safe pointer, sort of like a what they call. I think it's a smart pointer. And another pointer is basically you have a you have a, how to say, you have a heap allocated data, and the pointer itself going to be in the heap. So if that is case, then Rust itself couldn't know about whether couldn't know anything about, basically Rust itself cannot know anything about um, you know these pointers and data exist. Basically, it will not know anything about those things, because once you make them into a heap thing, it's all up to you, right? The another set of thing is basically when you have a variable, basically you have a pointer which is in a stack, and the data, as usual, is going to be in a heap. But the thing is, you can increase the reference count, basically meaning that as long as the even if you are increasing the reference count, means you have a data, right? But now the pointer is basically in the stack, so it's a single pointer. When it goes out of scope, Rust will watch, Rust will see, and oh, okay, no problem, we can clear this data for now, we don't need it anymore, then clear the data, right? Through reference count, you can increase the count of the reference to the data, which is now two pointers can basically pointing to the heap allocated data. So one, if one becomes out of scope, the another one is still pointing to it. So you don't need to worry about whether it's cleared by Rust or not. Okay, it's basically Rust cannot clear that. So there is a lot of type of sort of pointer, but I think this is so if it is an unsafe block, it's just meaning that it's going to be also in it's going to be, I'm not sure, it's going to be a heap allocated pointer or stack allocated pointer. Okay, let's just copy this code, because nothing fancy here, because every computation is going to be happen here. So for this case, we can build GPT. The Remember, but now I'm just basically copy pasting a lot of the codes from LLM to my code base, but that's not actually a good thing to do, because yeah, you can do that, but you need to be careful about how you need to basically know and understand how the code works, right? If you understand them, no problem, you can copy paste, because you know everything. Okay, this code working fine, or if you introduce any sort of bug, you need to be careful about that, right? So just you cannot just blindly just ask something and copy paste into your code base, because sometimes it's going to be break things, you know. Okay, for now, okay, think it seems like we have enough operators. I think we have a lot of them. Still, we need to implement a lot of them. Okay, for now, still we need to take care of this for the set of vector and power. Basically, you are you have a matrix and another matrix, and you are basically exponentiate with second matrix power. Basically, you can think of it as like matrix A have a 10 elements and matrix B have a 10 elements, then matrix B going to be the entire elements in the matrix B going to be the power of entire elements in the matrix A according to their index. Heavily optimized, no unsafe needed outside the um, SMEC call. Basically, I need if I'm including this, but now I'm actually I don't have a much understanding of how this library works, but I'm including this. But if you are including something in your project, you need to go to their documentation or GitHub page or anything and read about them, how they works. Then you can basically implement them. Why am I saying that is because you need to basically understand them at least to some extent, so that you can avoid bugs and any sort of things, right? So for now I just yeah, include this without any deep reading or something like that. But pretty soon, once I finish once I finish this thing, I need to I need to do sorry for that. I need to do basically a lot of test and experiment with this, then only I can trust uh, this didn't include any sort of box like that. So for now, let's just see. I think we defined enough operators. Let's just see whether it actually work or not. So we have a tensor and data. Um, so it's going to be grad. Okay, so this is another API for filling those elements shape. So what we need to provide is just it's going to be unself.default. Default is gradient true. By default, gradient is true, and the sum back it's going to be actually wait a minute. Yeah. So gradients are live in tensors, but not sure. Okay, it is what it is. Let's just check it. Okay, just where is the main OC file? Maybe we can check like this. So these go let's create Yax, which is a tensor. So it's going to be take something like this, and let's say 5 comma 5, and it's going to be so the random number. Okay, tensor the distribution, I think I totally forgot about that, because the distribution thing is very important, because now the tens actually Okay, what is it? For new API, it's going to be take a shape, then grad recur. Okay, so this is not optional, right? So boolean, okay, it's going to be a vector. Now let's just use this, you know, library, use rand, how we can generate a random number, right? It's going to be this, just we define that in here, dropout, right? As you call this method, then you are going to generate uh, a float 32 number, but okay, I just asked, hey, I want to use random number generator where basically generator, but it needs to generate a number between 0.5 to 0. Shit. Rand. Okay. So call this method, then get a range. Then include both the endpoints. If you want to exclusive upper bound, then some data, it's going to be 0 to size and dot collect. So let's just do that. Okay, that's the tensor class. So here I have something like this. So the data, right? So this thing is actually, so it need to generate, so it need to be generated by the random number generator. For now, let's just, how can we do this? Maybe we can create some variable here, but that's going to be inefficient, right? So instead of that, maybe, so it's going to be take a range. Actually, it's going to be take a size. First it takes size, then it's going to be take how many elements. Mm, so we need to do something like this. It's going to be 0 uh, to total here, and we are basically call map on it, and it's going to be basically do we why we are actually what okay, whatever inside of it we don't care about that, and then we are basically insert this, what is this gen range from 0 point, so it's a minus, it's a 0 0.5, and what it's going to be 2 dots, and 0 0.5. So you finish this, then collect. Then it's finished, but before that we need to that new dot rng is equal to random number, so rand dot thread, that's it. So this thing, so this thing actually returning vector f32, that's what we need, so we can do something like this, and you know this work, not sure, but I think uh, so I think it will work. So I just then go to the main. So basically we need to turn off a lot of this because there is a lot of code in those files are not basically ready yet. They're gonna have a lot of bugs. So the only thing we are going to use here, only thing we are going to check here is this um, this tensor struct, tensor class or tensor struct, whatever it is. So now we can basically send type, and it's going to be use as, let's say 5,5, and boolean, let's say it's false. FALSE, right? Then type, I just for don't take this seriously. I'm just filling some normal thing, filling some text here, but I'm basically created this parameter for another purpose, but for now it's fine. So and so we have now, and okay, let's change this to y, and let's check this. Okay, what are the operators we are defined? So first thing, x dot reload, and sorry, it's a reload. Next, sigmoid, next sigmoid, next tanh, next next what, neck, next so actually okay, for now it's just fine. So, relu sigmoid tanh, let's just check this. Let's just see we can have an error. Okay, and another thing, let's just I think let z equal to x plus y, and our favorite now, mute, actually let mute z equal to, what is it, how, what is the, so okay, we define that it's going to be a mat model, and we need to so wait a minute, so it's going to be a mat model, and it's basically need to take so okay, let's just test this and see. Okay, and we have cargo run, sure we have a lot of errors. So what is it? So I think another thing I just basically forgot to implement this rand, actually it's a rand, I think it's a 0.8 or something like that. run. We still have a lot of errors. Let's go through one by one. Private module. So actually, yeah, where we, yeah, here we need to do something like this. And another thing, module is defined here. Where, first of all, did I have that file? Do I have the file called lib.rs? So it's instead of that cargo. Okay. So we don't need to worry about for now. No method name get rate or change. I think it is. What is the name of it? Where is it? Sure, it's get. Yeah, that's what I just used here. Then no method named found for struct the current scope. Did I mention this struct thread? Actually, thread or rand thread orange. Yeah. Okay. And another thing. Then why are you saying that no method named found for struct at the method is available for thread orange? Item only can use the if the trade is in scope. Okay, I'm using here. Do I need to include that in my main file? I'm not sure really, but maybe. Trade RNG which provides get and an implement but no scope, not in scope. Add this. Okay, add this. Missing the field operation and actually where is it? Tensor. So I'm basically default. It's also default. Operation none. So then what is the problem? How many fields I have? 1 2 3 4 5 6. Basically have 1 2 3 4 5 6. It's a default. then where it is coming from. Missing field grad, recur grad operation, and one other field in initializer of tensor. I don't know where it's actually coming from. No method named string from the string. Actually, I have a parameter for this, and so it's a toString. Yeah, that's my bad. My bad. Current scope. So the reason because it's not in there is because I haven't dot binary ops. Actually, it's urinary. Not binary. What is the spelling for urinary? Sorry for that. It's my bad. Okay. It's really representing a very wrong meaning. I need to be get it's not something related to programming. Of course it is urinary operator. It's my bad, sorry for that. I need to get familiar with I need to basically, yeah, I need to improve my skill English. That's what I have to do. And this grade is actually we don't need this because I'm implementing tensor method in there, so that's fine. Okay, let's run this. And let's save this as well. And linear, we're not using linear. And so now we are much less error, but still help replace this. and expected identifier found reversed keyword. Where it is expected, or what you're expecting. It's this r slash thing. Who knows? Let's just add this. Let's see, maybe works. Maybe it will work. Format specifier. Binary ops. Where it is. So for now, let's just make this. And this is one of the cool thing about Rust compiler, because it's basically gives you an intuitive error where you can understand them, resolve them by reading the error. Consider importing this trade where I need to import this binary ops. Of course I did that, isn't it? So reset tensor. Put it in a binary. Okay. Mul divide and a private module that's defined here. Okay, let's just clear this up and run it again. We do have a lot of errors. Expect named lifetime parameter parent. Okay, I need to give a lifetime. Okay, but I'm not running this. This is use a random number pro. Why this is so do I need this is a private module. Sure. Still I'm not very good at Rust. It's RNG or it's, what is it? But how can we actually this will not work, right? It just ask GPT for it. Using it and thread here. You're very close. The issue is just importing. Replace it with this. Okay. Actually, it's in here. Yeah. And here we don't need. Tensor add might be missing for a tensor. Okay, I think we are about to cross 2 hours, right? Is anybody watching our live? Just see that I haven't actually. So again, it just does, right? Really have that. Do I need to simmer? It's going to be take a while. Trust compiler is not a flexible thing. Associated function, not a method. No, it is a associated. Actually, wait a minute. So I'm creating this. So x is what? X is X is a tensor, right? And method, and we are basically implementing tensor here, and its associated function. So if it has a self parameter in it, it's going to be a method, right? If it doesn't, it's going to be a function. So that's what they're saying. So interesting. Let's just change them. um, and it's going to be um, relu and x, and relu is basically coming from where? Can I do like this? I just say it's actually come from urinary up, I mean urinary operator. uh, it works because we can tensor I might be missing. That should meaning that um actually it's taking a self as a thing, right? So it should be a method, but the thing is it's going to be actually what it is. Crashed. Wait a minute. So it's going to be take some time to resolve this. First, hmm, but I changed that, didn't I? Or okay, my mind is basically not working here. I don't know why, but I just saved the file, didn't I? Come on. Oh, yeah. Still, I have this, but green.rs. Giving the exact code that's giving the error is from maybe it's a 60. No, it's actually, yeah. So, yes, and um, so it's not around, it's the urinary ops also give the same error. I don't know why, but it is what it is. What is it? Third. See. Another thing, I'm basically okay. For now, leave this as it is, and tomorrow I will basically anyway we just trust. 50 zone. How much are 50? Cannot add. Actually, implement add trade must be implemented, but I'm implementing that in a binary ops. Can see that here, right? Implementing tensor. First of all, why we are actually didn't I save the file? I think that I saved it. Just keep coming. $59. So it's in a tensor line 59. This is where it is. And okay, that's my hyper. Okay, let's run this again. Not found in the scope. Yeah. So basically we are implementing this add trade in a different file. So you know, I have a error called couldn't find the add trade implementation implementation for my tensor struck, and I'm basically implement that in another file, import a tensor shared struct the and but if you are seeing this error, where you are importing ops. Okay, CRAD. This means you are trying to use tensor type, but you haven't implemented the add rate. Can't find it, but I actually did it. I actually did it. I mean, I did that, isn't it? So the problem is something this. So let's just see. So we don't have that. Reload not found in scope, of course. Element wise up. Expected tensor data, font tensor. And this to trade which provided but not in scope because you want to import it. That doesn't make sense. So the only thing, the major is this rant module that is basically making the code sick. Okay, here we having this is a self. Uh, like trying to move them, not clone them, because so okay, okay. Okay, for now, just leave it as it is. I need to, I need to spend time for all of this, and no, it's not, um, yeah, we can spend some time for it, but it should not be in our productive hours. So in our productive hours, we need to focus on as much focus on writing code and thinking deeply about structure, implementation, and everything. And okay, I think that's enough for today. And um, if you're watching our